Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on October 16th, 2025, about 2 days ago. The striking result is that interactive tool use lets state space models generalize in length, with Mamba reaching 10 to 1000 digit multiplication at 100% in certain settings. The paper is titled, To Infinity and Beyond, Tool Use Unlocks Length Generalization in State Space Models. And as we'll see later, the implications for efficient long context modeling are quite significant. Beyond that, this paper proves fixed memory models fail on true long-form tasks unless they interact with external read-write memory tools. Alright, the previous segment set up the limitation and the tool idea. Figure 1 contrasts 3 training sources for a coding task: single-turn commands, iterative interactive edits, and distilled agent traces. The left panels illustrate how the trajectories differ, which matters because interactive steps expose read and write behavior. The right plot shows pass rate versus number of functions. Transformers lead on tiny code bases, but Mamba, trained on interactive or distilled traces, holds accuracy as size grows past the 16-file training mark. So the previous figure contrasted coding trajectories. Figure 2 shows how the same idea plays out for arithmetic with a pointer memory tool. The left panel illustrates an interactive sequence where the agent issues read and move commands, receives observations, and writes partial sums and carries, which effectively gives unbounded working memory. The right plot reports accuracy versus sequence length. Mamba stays near perfect up to 1000 digits. LSTM dips slightly, while transformer baselines collapse past training length. Alright, the previous figure highlighted arithmetic with pointer memory. Table 1 summarizes synthetic results across tasks, which compare Mamba, LSTM, GRU, and transformer baselines. For n times 1 and n times 2 multiplication, Mamba reaches 10 to 1000 at 100%, while LSTM and GRU top out near 100 digits. Logical graph generalizes to about 1000 nodes at roughly 98 to 100% for the state space and recurrent models. Hanoi remains hard, with Mamba reaching 8 to 12 at about 49%, and others stuck at 8 to 8. So, Table 1 summarized the gains. Figure 3 illustrates the 2 task setups that drive those results. The top panel shows a random logical graph with labeled variables and a query node. In the agent issues find calls to search earlier nodes, which enables scalable reasoning over long graphs. The right side presents the corresponding symbolic program that the agent must evaluate. The bottom panel shows a code dependency graph, and, on the right, an editor view, where the agent navigates files and applies fixes. Well, the previous figure laid out the task setups. Table 2 reports recursive Tower of Hanoi results under the interactive tool protocol. Mamba jumped from 7 to 8 disks at 100%, LSTM reached 7 to 9 at 83%, and GRU hit 7 to 8 at 100%. Pythia stayed at 7 to 7 with 100%, while Mistral managed 7 to 8 at 87%. These numbers show better length generalization for state space and recurrent models than for transformers. So Table 2 reported Hanoi scores. Figure 6 presents 4 accuracy panels under the tool protocol. The 2 multiplication panels show Mamba and the recurrent models staying near perfect across 1 to 1000 length, while transformer baselines collapse shortly past training size. The logical graph panel similarly favors state space and recurrent models, which hold accuracy as graphs grow. The Tower of Hanoi panel shows gains but sharper drop-off at 9 disks, indicating limited extrapolation for this recursive task. Wrapping up, 2 takeaways stand out. Fixed memory models cannot solve true long-form generation alone, and interactive tool use with external read and write memory unlocks strong length generalization across arithmetic, reasoning, and coding. The broader implication is clear: prioritize tool-using agents and curate interactive training traces. That is it for the AI Research Roundup. I am Alex. Thanks for listening.